Hello, today we're looking at retaking simplifying expressions using negative and zero exponents. So our directions say simplify the expression and write using only positive exponents. So let's take a look at number 6 here. We have x to the power of 2. That already is a positive exponent, so we're just going to leave it like it is. And over here we have 16 to the power of negative 4. So negative exponents, we need to move to the denominator of our fraction because the negative really tells us we're dividing by 16 4 times instead of multiplying. If it was 16 to the power of 4, that would tell you to write 16 4 times. But this is telling you it's still 16 4 times, it's just dividing, it's on the bottom of our fraction. So we have x to the power of 2 on the top, and then our 16 to the power of 4 is now on the bottom. We divided by 16 4 times, so we're not writing the negative. The negative tells us that we need to move the exponent. So we can't simplify x and 16 because they're not the same letter or number, so that's our answer. We're done. Our goal is to have all positive exponents. On this next one, the y to the power of 4 is already a positive exponent, so I'm going to leave it there, y to the power of 4. But this y to the power of negative 8 is a negative exponent, so again, negative means we have to move and make the exponent a positive, so that's going to the bottom. So now we also have y to the power of 8 in the denominator. So we have y to the power of 4 times y to the power of 8. Remember, move and make the exponent a positive. There's nothing on top, it's really just a 1. But don't stop here, you guys. We have a lot of y's in our denominator. They're all y's, so we can count them all up. We have 4 y's, 1, 2, 3, 4. And then 8 more, 1, 2, 3, 4, 6, 7, 8. Instead of writing them all out, we're just really adding our exponents. How many y's do we have total? Well, 4 plus 8 should give us 12. Your answer is not 12, it's y to the power of 12. We multiplied y 12 times. And it's all in the denominator, so we leave it in the denominator. Next, only thing we need to move are our terms with negative exponents. So this is the only term with a negative exponent that needs to move to the bottom. This is staying where it's at, and this is staying where it's at because it's already written with a positive exponent. So we have g to the 5th on the top and g to the 3rd on the bottom. But now this piece, g to the power of 6, is also on the bottom. Move and make positive. It's really dividing. It's going on the bottom. So now we can count up all of our g's. I'm going to start on the bottom and think, how many g's do we have total down here? The g to the power of 5 was already there. And then on the bottom we have 3 g's here, and then 6 more. We're just adding our exponents together. We have a total of 9. But be careful, we can still move further. We have 5 g's here and 9 g's here. What do we do when we have the same letter on the top and the bottom? We can cancel them out. We have 5 g's on the top and 9 on the bottom. Anytime we have the same letter or number on the top and the bottom, numerator and denominator, we can eliminate. So wherever we have the smaller number of g's, those are all going to go away. 5 of them got eliminated, and we have 4 left over. So 9 minus 5 gave us 4. So we have g to the power of 4, but it's in the denominator. It needs to stay in the bottom. There are more g's in the denominator. I wrote that a little bit big. We have one question left. I'm going to make that a little bit smaller. 1 over g to the power of 4. Alright, next, number 9, we need to write using only, again, positive exponents. So this is our only term that has a negative exponent that needs to go to the bottom of our fraction. Remember, if we have a number, like let's say we have 3, and we want to move something to the denominator, there's always a 1 because 3 divided by 1 is still 3. So if there's nothing there, you can put a 1 on the bottom, but we don't really need it because we are moving our ends to the bottom here. these ones are moving to the bottom. So we have n to the power of 7 on the top, and just an n, that's really only one n, so it stays right there. And then now 3 n's in the denominator. We can keep going. On the top, how many n's do we have together? We have 7 and 1 more. We really have 8 n's. And then n to the power of 3. Just like over here, we can cross them off, simplify. We would have 8 on the top and 3 on the bottom. So some of them are going to cancel. 1, 2, 3 of them are going to go away, and we'd be left with 5 left over. It's hard to see those ones at the end there. You can also look here. 8 minus 3 would give you 5. Left over 8 take away 3 would give you 5. So we have n to the power of 5 in the numerator, or just n to the power of 5. These 3 canceled out with 3 of these and left us with 5.